Yeah, so Karthik, Prabhakar, I'm the Director of Solution Architecture at Tigera, which is the company behind Project Calico. But we've also sort of been picking up other projects over the last many months and years. So as an example, we are the co-maintainers of Flannel with CoreOS. We are also the co-maintainers of CNI, which is the network plugin interface used in Kubernetes. We are pretty active in SIG-Network, so there's lots of stuff going on there. For the last many months, we've actually been very active in Istio, working together with Google and IBM, and a couple other companies as well. There's one. Have you guys heard of Istio, by the way?
Yes.
Okay, so make a brief mention and how it fits with this. Oh, awesome, great. So there's a sort of a underlying theme around just connectivity, application connectivity across Kubernetes. Kubernetes is something that we made, that's been sort of a core platform that we've been focused on very heavily, partly because it's sort of a mutual thing. So you look at a number of the design artifacts in Kubernetes, it sort of mirrors a number of design ethics in Calico and vice versa. And so Calico has also been joined together with Kubernetes. That's it, Calico and other projects work across multiple orchestrators, including VM orchestrators. But generally, the company is focused on application connectivity, right, on Kubernetes and cloud native workloads. That said, talking to some of you, I want to get also a feel for sort of your experience levels with Kubernetes, experience levels, your sort of interests, what you'd like to talk about. What I had planned today was sort of a little bit of a genesis of how we are where we are, which is sometimes people go about deploying things without realizing why certain decisions were made, why Kubernetes CNI is the way it is, or why Calico is the way it is, or why other plugins do what they do. So give you a little bit of sort of the history there, but then also a bit on Calico, how it works. I can also talk to Flannel, how it compares and how it is compared to the broader ecosystem out there. Had a demo, I was sort of working on some of the YAMLs on the way over, so hopefully fingers crossed that it functions. Sort of inviting problems in the demo lots here. But basically showing some of the more advanced network policy concepts, and I'll also talk to how people use network policy and focus on sort of dynamic cloud native security in Kubernetes and other realms. But also Tigera as a company has a lot of operational tooling we built on top. And I'm going to give you a demo, a little bit of that, but heavily focused on sort of network policy, where it is today, where it's going, networking. But that said, some of you guys have been using Calico for a while. Show of hands, how many of you have never used Calico before? Okay, so majority, so I'll sort of talk to that. How many of you have never deployed a Kubernetes cluster before? Okay, so, but you sort of familiar with Kubernetes, high level what it does. So I'll try and touch on it, okay, a little bit. And when we do a demo, you can actually take a, hopefully the cluster should come up pretty quickly so you can take a look. What are you guys interested in talking about? Any sort of top of mind issues for you these days? From sort of to scope it out a bit in the theme of sort of application connectivity in Kubernetes, networking, service meshes.
I'm really curious about how to, so we've had Calico for network policy and networking for 2 years. Or a year and a half, it's a long time. And we basically use networking policy never. And it's because I'm too busy doing cluster admin stuff. I don't really have a lot of control over running it, but I'm like, is there tooling, is there stuff to help understand where things are going so you know what to block and like how to, so that last bit about tooling, about like doing more than just making network policy YAMLs, but like really understanding it.
Yeah, so I'll touch on that a bit. Yeah, in fact, I'll show a couple of things that might be useful. Cool. Okay. Any other sort of top of mind issues?
For me, performance troubleshooting.
Cool. All right. Yeah, we can talk to that.
What was that?
Performance troubleshooting. Question was any sort of performance troubleshooting. So from a Calico perspective, the networking is just IP networking. So performance troubleshooting very simply is how you troubleshoot IP networks. But we'll talk to that. Yeah. Any other sort of Kubernetes related artifacts or?
Just for me, how do you decide the various policies versus Calico versus Flannel versus?
Sure.
How do you go about making that decision and evaluating?
Perfect. Yeah, question is like, how do you sort of evaluate the different networking options and, sort of things you can use to decide, right? So we'll kind of talk. And by the way, don't make it about me talking. You use Calico, chime in. Other folks who have opinions, chime in with your opinions, right? This is sort of an interactive, it's a meetup, right? We all have experience, right? I can learn from you guys as much as you, but kind of.
Do you also have cooperation with the Helm side? Helm?
With what, sorry?
Helm? The HELM?
Helm.
Helm.
Okay, I'm sorry. Yeah, I'm sorry. So Helm is absolutely, so that Helm is sort of a ongoing, I mean, it's how you orchestrate applications in Kubernetes today. It's sort of the preferred way to do that. And there is ongoing work on the Calico Helm chart. It is really there. There's a couple of, I should probably introduce Calico and CNI before I come to this. So the challenge is Helm requires a management server called Pillar, which needs to be networked. But Calico is what provides the networking. So there's a circular dependency on doing a Helm chart for Calico. That said, there's sort of a kludgy workaround, and there's a more cleaner workaround, which is what we're supposed to. But yeah, we'll come back and touch on that.
As far as like, how we've gotten to where we're at, we run on Container Engine, which doesn't require necessarily as much as other platforms because Google built both. I'm curious when and how you would use it there both. I saw an announcement from Google and Calico a couple days ago.
I'm glad you saw the announcement. So the comment was he uses Google Container Engine, and it sort of does everything for you. So you get a full Kubernetes cluster. Guess what? Google actually used Calico and offer it up to customers. So when you deploy a cluster in Google Calico Engine, you get Calico policies as part of that, right? So it's essentially Google that's built it under the covers, and you just get to use it. So let me introduce Calico, and then we can sort of dig deeper into the different clouds and what they're doing. By the way, I know this was also announced on the Azure Meetup, the Utah Azure Meetup. Anyone here from the Azure Meetup? In case I just want to make sure I say welcome and talk about what's happening in things like ACS. Okay.
Hey.
Anyone tried spinning up a Kubernetes cluster with Azure yet? Okay, cool. So that's folks. By the way, any of you tried Windows yet? Oh, cool. Okay. FYI, if you follow Calico users, there was a call for beta users for Calico on Windows. FYI, in case you're interested. Okay, cool. So a little bit of the genesis of how we got here, and I don't know why I picked this image, but in the early days of virtual machine networking, people figured out, hey, if you want to get VMs to communicate, we'll just create an overlay, right? You have a VM here, take the packets, put them inside another packet, and magically, just because it's an Ethernet header, it makes it sort of more secure, right? So that's sort of the early days of virtual machine networking. You had sort of distributed vSwitches, sort of the early primitive days, and that sort of evolved over time. And then when you got to the VM orchestration platforms, they sort of expanded on that, and they said, oh, if VM A or application A, part of VM A needs to talk to app B, put them in an overlay. Now VM A needs to talk to VM C, put that in a separate overlay. And pretty soon you sort of keep evolving that, and you end up with sort of this massive infrastructure managed overlays with, packets inside packets, lots of additional overhead from a performance perspective. Many of the overlays tended to use layer 2 technologies, and then they started working on bridges and vSwitches and connecting them up. And then you have, and this I think is a example from the OpenStack documentation. I'd like to pick on it because I spent nights and weekends troubleshooting this, the last 3-4 years when I was working at OpenStack. But like Kubernetes from the early days was a little bit different. And I took a little bit of a different approach. Oh, by the way, I love this picture as well, because I'm sure all of you guys, if you've troubleshooted networking, whether it's performance, actual just connectivity, when you have this mess of overlays, you could have like two workloads running on hosts physically adjacent to each other. And when you have a complex mesh of overlays and like vSwitches and bridges, and you can't figure out at 3 in the morning why a packet going out this OVS doesn't come out on the server next to it. It is crazy how much time you spend troubleshooting that, right? So that's sort of what we're trying to get away from, right? We're trying to keep networking simple. The network is something that people shouldn't be scared about. right? So we're trying to sort of roll back some of those bad history here. And so Kubernetes, a little bit of context for some of you who are sort of new to Kubernetes, and even this is sort of evolving quite rapidly as Kubernetes is always evolving. So there's a sort of a set of abstractions that Kubernetes chose from a connectivity perspective. So first of all, in terms of CNI is the networking abstraction that Kubernetes chose as a way that different network plugins can provide connectivity to pods. Pods, obviously, most of you guys know what a pod is, but essentially that's multiple containers with a shared network namespace, right? So that's sort of a artifact of an application, if you will, a container with sort of a network namespace around it. And so CNI was the plugin abstraction that was chosen in Kubernetes. It's very simple. You provide a JSON specification with an executable and essentially things like add a network and delete the network, right? And different network plugins sort of implement different approaches. So you can start bringing in your traditional network overlays. You can use other sort of networking approaches. But fundamentally in Kubernetes, there are certain assumptions that are made. One is that every pod in Kubernetes has an IP address that is unique across the cluster. The second thing is that every node has an IP address as well. So Kubernetes basically assumes IP connectivity and that it is consistent within the cluster. And then it's ultimately up to the plugin implementation to decide how it wants to get that connectivity from pod to pod across the network, right? But one fundamental change that Kubernetes chose is it chose to decouple this concept of network policy as a separate declarative approach. So it provides sort of a declarative language, typically YAML. You have YAML syntax, where an application developer, as part of the pod spec, whoever is deploying the application, you can specify things like how you want to use labels, you label objects and label selectors, and then define network policy that says, how you want your applications to be isolated. So as part of network policy, you can have this rich policy language that says, I'm going to label this thing an LDAP server, and I'm also going to label it production. I'm also going to label it customer A. I'm going to label this LDAP client, and it's going to be labeled staging, and it's labeled customer A. And then in network policy, you say things like, I'm going to allow all LDAP servers to talk to all LDAP clients over port 636, LDAP-S, as long as they have the label customer A, right? So you can sort of do that declaratively. And what that means is, now that you can use a rich policy language for isolation, you no longer need to rely on low-level infrastructure artifacts like network overlays for isolation. So absolutely, if you have a network plugin that does it with overlays, you can absolutely bring that in. But a much cleaner approach is just use standard networking, right? And so that is a fundamental architectural premise that Kubernetes brought forward. And this almost identically mirrors Calico's foundational architecture, because Calico's architecture was based on the fact that the founders, my boss, the CTO, and other co-founders were looking at this going like, why do we need overlays? Because that's really not the best sort of abstraction for isolation. You can do this isolation in a much cleaner way with a policy language. And then do simple networking, right? And so that's sort of a fundamental artifact. I'll come back and talk to how Calico works, but Calico's design sort of mirrors some of those design decisions in Kubernetes. Aside from that, Kubernetes, you also have the concept of services. So you have things like kube-proxy, where given that Kubernetes spins pods up and down, so we have a Redis application instance that might be a dozen different Redis pods, right? So you might have a replica set in Kubernetes that says, always have 12 Redis instances running. And if one of those dies, Kubernetes will spin up a new one, which means the pods come up and down, the IP addresses change, things are transient. But you have this concept of a kube-proxy that does the NAT and magic there to make sure that when someone sends a traffic to this Redis service IP, that gets translated into one of the pods behind the scenes, right? So that's sort of a nice little service abstraction, so that as Kubernetes changes pods behind the scenes, you have a nice front-end IP address or port or something else that an external application can talk to. You also have the concept of Ingress, which is a way to have something like an Ingress resource defined and an Ingress controller that implements it. where traffic from the outside world coming in gets terminated at the Ingress controller. The Ingress controller looks at things like headers or HTTP headers or other data, application data, and then transparently redirects to a backend pod that's providing that function. So that's sort of the concept of Ingress, and that's also evolving as we speak, by the way, in Kubernetes. And there's other sort of artifacts, things like kubedns and how you map services and how you do service discovery using DNS in Kubernetes, typically using kubedns today. That's something that's in the process of being moved over to core DNS. And these all sort of abstractions that work together, and all of these also continue to evolve. One of the more recent concepts that people are sort of embracing quite rapidly is this concept of a service mesh. The one that's getting a lot of attention these days is a service mesh technology called Istio, which is a project started by Google and IBM about about a year ago, roughly. And Tigera, the company I work for, we've been working with both companies going back many months, well before it was launched. And the concept of a service mesh is that historically, when you wanted to do some of the more advanced functions like having encryption for traffic, for applications, for getting detailed tracing, you typically linked in some sort of a library into your application. And the library would perform all of these additional functions for you, like tracing, being able to troubleshoot, give you more in-depth statistics. The concept of a service mesh is you take all of those library functions and you push it into a separate standalone component. In the case of Istio, the component that it uses is called Envoy, which is something that Lyft, the ride-sharing company, open sourced over a year ago. And what this is a very lightweight container that runs as a sidecar to your application container. It intercepts all traffic from your application, and then it performs all of these networking functions or connectivity functions on behalf of the application. So as an example, it can do things like transparent to the application, being able to do TLS, mutual TLS. It has the ability to assign a well-defined identity, service identity to your service, and then using that service identity and certificates to be able to do encryption, to be able to transparently monitor performance as application flows happen through the sidecar proxy, and use that information in things like more advanced traffic management. If you start to see performance to decide if the application instance being slow, maybe you do a circuit breaker and fail early, or maybe you do load balancing somewhere else. Being able to do more advanced traffic management, maybe based on application headers. But doing all of that independent of the application. So you could be running your application, not have to worry about adding a network, you're just sending normal HTTP traffic. And all of these other functions, including troubleshooting, tracing, being able to generate service graphs of connectivity, being able to trace your application flows, what performance is seen, doing all of that sort of transparency to the application. And that's a pretty, it's been getting a lot of attention. So Envoy is being used as a sidecar proxy. Istio is the control plane that programs all of these individual Envoy agents or Envoy sidecars running next to your applications. And it's something that we've been involved in as well. And that's sort of increasingly bringing some interesting capabilities into the Kubernetes ecosystem. And that's actually in the process of being expanded out to virtual machines as well. So now when you talk about Kubernetes, talking to VM environments or other orchestrators, this sort of provides a nice level of application glue that connects it all together. Right? So these are all sort of artifacts that work hand in hand from a connectivity perspective with Kubernetes. And from our perspective, all of these work very nicely together. Obviously, there's some sort of melding as some of these projects grow. And things like policy, Calico does layer 3 and layer 4 policy. Istio and Envoy do layer 4 to layer 7. And yeah, there's some overlap and there's continuing evolution, but these sort of blends in very nicely. But fundamentally, all of these artifacts sort of work hand in hand. In some cases, because with things like Envoy, you can do advanced traffic management. You may not need the coarse-grained sort of redirection that kubeproxy does. So you might bypass kubeproxy in some cases. Other cases, you might use kubeproxy. So there's sort of an evolution, but all of these artifacts are available to you. How you deploy and architect them in your deployment is really up to you based on what makes sense to you, right? Question?
I'm curious, especially with Envoy and Istio, like what are their targeted kind of performance overhead? Like I've looked a long time and haven't found.
Yeah, we could go to this. So Istio is still very much an alpha project. We just the 0.2 release just came out, and Istio has multiple components. There's the mixer, there's the pilot. 0.1, there wasn't any caching on mixer, so every request had to go in to check policy. Now that's caching. But that said, Istio is also a modular project, so you can decouple it for performance if you want to. That said, this is sort of going off into a tangent because we could spend like, I've actually done the Istio talks numerous times with various folks at Google and IBM, and you could spend hours talking about Istio. There's a lot going on there, just tons of stuff. At some point, I think there needs to be an Istio focused meetup.
Yeah.
Right. So maybe we can go back and do that, right? There you go.
So before stepping away from
Yeah.
So there must be some kind of target like per request. Like, I mean, what's
Yeah.
the ballpark like is for an acceptable?
Yeah, so there's actually there was a thread recently. I don't know if this is a public thread. I think it might have been a public. It's all public. One of the most public threads. There was a conversation with a few folks at Cloud Foundry who have been looking at Istio for within the Cloud Foundry ecosystem, and some of the scale targets they were looking at. And I know in that sort of thread there were some numbers quoted as to, you know, how many policies, how many nodes, the number of pods, all within a single namespace. I can sort of dig that up for you after the meetup if you want to stick around. I'll get those numbers. But I will say that right now, Envoy itself is very stable. It's mature. LIMP has been running in production for a couple of years now.
Right.
So it's pretty rock solid. Istio as a control plane for that is still alpha, but even that is sort of evolving very rapidly. Performance, I would not say is sort of the, I mean, there's still a lot of areas of potential bottlenecks, but people are familiar with that and they're working on approaches to work on scalability, including cloud hardware.
So this is a separate kind of project outside the Kubernetes, is not part of the Kubernetes project, right?
Correct. It's a completely separate project. That said, it was developed first for Kubernetes. So Istio is developed starting with Kubernetes. Now it's sort of, but with the objective that makes sure it's modular so you can plug it into other orchestrators as well. So now that work is happening to plug it into Docker, to plug it into VM environments. But Kubernetes is sort of the base platform that started out there.
So then there is no plan to kind of merge it together, right?
There's been talk. So, for example, there's been talk about in the Kubernetes, some of the Kubernetes maintainers about having a sort of a service mesh data plane, which is as sort of the default ingress. And the talk right now is about using Envoy as that, starting with potentially the 1.9 release. So there is sort of chatter going on, sort of a batteries included model, right? Batteries included, but replaceable. If you want to use a different controller, you can. But we'll try and make this easy for you by having the Envoy built in. So that's sort of it's still sort of early days for 1.9. So we'll have to see how that works.
But the reason that I asked the question seems like this should be kind of one fundamental building block for Kubernetes.
Absolutely.
That's sort of like, okay, why you guys have separate projects?
No, completely agree. This is Istio and concept of service mesh and Istio and Envoy. What they do is pretty incredible, not just for Kubernetes, but anytime you have any sort of broad services or microservices deployment across containers, virtual machines. And so absolutely, this is a critical function. That said, the world that we're moving towards, which is much more lightweight things, whether it's running as functions as service or whatever, this is all moving us to the world where things like policy, things like networking need to be much more adaptable, lightweight, simple. This concept of having heavyweight functions, network overlays, you have things that are bolted on and sort of fixed, don't really fit this model very well. So that's sort of the world we're going, right? So that's just an evolution of where we are and where we're going. And you guys, I mean, these are all pictures from 4, 5, 6 years ago. These days, obviously, the pictures are much more complex, and this is just showing the application flows at a high level, not the actual instances themselves. In these sorts of instances, if you have these sorts of deployments, if you had sort of traditional network overlays, going back to the question, how do you choose between sort of networking approaches? Imagine you had, these are just your high-level application instances, and each of those has like dozens or hundreds of pods, right? Each with an IP address. And if you had sort of overlays for each of those individual pods, you can imagine, you're going to need to rely on very specific vendor tooling to troubleshoot and get that to work, right? Or you could take sort of the Calico approach, which is keep the networking simple, right? And I'll talk about what Calico is. Very briefly, CNI talked about this being the plugin interface. There's a little bit of work going on, but for the most part, it's pretty stable. Essentially, it gives you a way to, so in Kubernetes, on every worker node, you have the kubelet that creates a new pod for an application instance. It calls out to CNI using the CNI specification and says, specifically it looks under /etc. There's a JSON artifact that says, here's the plugin specification to call out to. So the kubelet calls the CNI plugin. If it happens to be Calico or Flannel, or pick your favorite plugin, that would be a sort of an JSON artifact there that would launch the plugin.
One runs multiple, right?
Sorry. Oh, you can run multiple
Yeah.
as well. You can have there's sort of an ordering sequence there. Fine. Right. So typically with CNI, you get the basic add network, delete network. You can also have other things like different plugins have different implementations of how they connect the pod's namespace into the host. What Calico does, in fact, now what Flannel does as well in the most recent release is we simply use the virtual Ethernet. So Calico and Flannel don't do any layer 2 artifacts. They simply take the pod network namespace, connect it via virtual Ethernet into the host network namespace. So what goes in from the pod into the host comes out the host and vice versa, right? So we don't use any bridges or vSwitches, just keep it very simple. But CNI provides a sort of abstract interface. And if you start looking at how connectivity works across nodes, if you have multiple nodes, Calico also uses a data store in addition to Kubernetes, which also uses etcd. Calico can work with etcd, or we also have a mode called KDD, Kubernetes Data Store, where we don't have a separate etcd. We simply write to Kubernetes using what's called custom resources, and Kubernetes stores it at the backend using etcd. But we basically use a distributed key value store for synchronization of Calico data, right? And in effect, what happens is when a new pod comes up, the orchestrator calls out to the CNI plugin via CNI. In this case, it will be a kubelet on the node where the pod is launched, calling out to, say, Calico via the Calico CNI plugin. And the Calico CNI plugin says, oh, great, I now have a new pod. It gives the pod an IP address, typically using Calico IPAM. You could also use host local IPAM. There are sort of different IPAMs available. Calico IPAM sort of allocates IP addresses much more dynamically and more optimally. So you sort of don't waste addresses. Flannel uses /24 allocations to every node. So you're basically giving a /254 addresses to every node, right? Which sometimes can be wasteful. That's typically what you do with host local. But you have a choice of IPAMs that you can use with your CNI plugin. And so Calico's CNI plugin gives the pod an IP address and then writes the pod's information into its data store, which is typically either etcd or Kubernetes itself. And when that happens, what we do is we have a little agent running on the host. It actually happens to be running as a container itself. In the case of Kubernetes, we're running that pod. It's just a special pod with running in privileged mode. And what this Felix agent does is it receives a notification from etcd saying, hey, a new pod has shown up on your host. So what it does is it takes the pod IP address and adds a route in the Linux routing table saying, to reach this pod's IP, send traffic down this virtual Ethernet. Right? So it's a very simple, I know the IP address, I know the virtual Ethernet for the pod, it just creates a route saying, for this pod's IP address, send traffic into virtual Ethernet. And alongside Felix, we also have a little daemon that when you're using Calico for networking, it's not required, but if you're using Calico for networking, what we do is we look at the routing table and we see that, hey, there's a new route that's associated with a Calico virtual Ethernet. We now have to make sure all of the other nodes in the cluster know that this IP address is reachable here. And what we do is we use standard BGP for exchanging routes among different nodes. This is something that we automate, so it's all set up automatically by Calico, and it's between the nodes in the Kubernetes cluster. If you choose to, you can also choose to peer it with your infrastructure if your network admins like it. Generally, they do. but it's not required. But this is essentially a way to exchange routes between nodes. And what we do is we exchange aggregate routes. So typically it's a /26 or better in terms of the routes that are attached. So in effect, this pod comes up, the route pointing to the virtual Ethernet comes up, and then that route is advertised to other nodes of the cluster. And what we do with Calico is we use standard BGP. Why do we use standard BGP? Let's think about the networks at scale. What is the biggest network out there? Internet, right? What is the internet used for networking? BGP. And so we know this scales. So what we do is we use standard recipes. If you want to scale to thousands of nodes, there's ways to do that using route reflectors and other ways. This is standard network project, right? No real magic to it aside from the way we orchestrate the auto configuration of things like meshes. So the users don't have to configure it. So from a scalability perspective, networking in Calico is simple IP routing. So what we do is we create routes in the routing table, and Linux is doing the routing. On the case of the OS is doing the routing. So as far as networking is concerned, Calico is simply using the same recipes that scale to the degree of the internet. So when people challenge me on like, hey, what's the network scalability of Calico? Or someone's looking at, hey, what does this scale versus something else scale? Some approaches tend to create sort of overlays and have a centralized SDN controller. Guess what? Anytime you have a centralized controller, you have a bottleneck. Anytime you have, there are some that use gossip protocols. So there's different approaches. Calico uses standard network routing, right? So that gives you sort of something to consider from how you compare network approaches. Do you have a comment?
Yeah, so let me understand again with the Q proxy in this model, is it not being used at all? Because it sounds like the IP tables are being adjusted through Felix and other.
Yeah, Q proxy works independently, right? So Q proxy translates to a pod IP, right, and Calico does the pod IP routing.
Just the routing itself. You have to use Q proxy?
It's not required. You can actually, since Calico is using standard IPs, right, you can, if you pair with the infrastructure, you can actually use directly routable IP addresses, right? So if you want to, you can say specific pods are allowed to have direct external connectivity. Right. But other pods have to go through Q proxy, but Calico just works seamlessly. And the other function that Calico performs is network policy. And what this is when you have network policy that says things like all objects labeled LDAP servers should be allowed to talk to all objects labeled LDAP clients as long as they have the label production. That high-level policy intent is something that is stored in Calico's data store. And when a new pod comes up, Felix looks at the labels associated with the pod. Let's say it matches Redis server. Redis server doesn't match LDAP server. It doesn't do anything. Let's track it to all without doing anything. But if a new LDAP client pod comes up, LDAP client pod matches the label, says, okay, so now I'm not going to create network policy artifacts. And what it does is Felix creates IP tables, role specifically, it creates an IP set that says this LDAP client IP address is allowed to talk to the set of LDAP server IP addresses. And it's done as an IP set, which means it's a single kernel lookup. Right? And this is all done by every Felix agent independently, so there's no sort of centralized controller. And so this is sort of a very scalable way of doing network policy, which is why you look at all of the big cloud providers, they tend to use Calico policy enforcement because it gives you this very scalable way of doing network policy. And if a LDAP server disappears, Kubernetes kills one of the pods, then Felix gets notification that that has died, and it simply updates the IP set. Right? So it's a way to do in a single kernel lookup this policy enforcement. It is done at the point in which the pod connects into the host, so it's actually at the very end point. And so you get this sort of very fine-grained isolation at the very edge of where the workload connects into the infrastructure. Which means from a networking perspective, it's simple IP traffic. The default mode with Calico that a lot of people use it with is no encapsulation, which makes it really simple. Troubleshooting is easy. You're just looking at IP traffic. You're using all the tools you used for the last 40, 50 years for IP networking. If you work going across multiple public clouds where you don't have the ability to share sort of routes with the infrastructure, Calico also has a mode called IP-IP, where you take the out IP packet, encapsulate it in an IP packet. It's not a full-on overlay, it's just a tunnel, and it's not being done statelessly. There's no state that's maintained by Calico. Just put the outer packet in the inner packet. Calico Policy can also work on top of Flannel. So for those of you who want a traditional overlay with something like VXLAN, which Flannel does, you can actually do Calico Policy on top of Flannel. Or in the case of some of our cloud providers, they have their own SDNs behind the scenes, and they use Calico sort of on top of it, providing policy.
I was just saying, you can also, and I was just pointing out because I really like it, you can do IP and IP just from subnets as a 2.5.
Yeah, I think 2.4, 2.5, yeah, exactly.
And
Yeah.
so you don't have to do one or the other. You can say, look, if you're sitting in the same subnet, just go.
Exactly.
You need to cross, and obviously whatever your router doesn't know about your routes, and then you encapsulate only for that traffic.
Exactly. Calico automates that. So essentially, if you're running in an, for example, in an AWS AZ, where you have layer 2 adjacency, you would just do non-encapsulated. And if you're going to a remote AZ and you need to cross or go across multiple VPCs, for example, then it encapsulates. So you sort of automates that for you as well. In fact, let me sort of switch to a demo because I think that will give you a more idea of how this all works. This is sort of what network policy looks like from a high level. You know, it's just giving things like labels to pods, and then you use label selectors, and then say, and then label database and label compliance equals PCI should be allowed to talk to, and then label front end and compliance PCI over port 6379. So that's essentially what this network policy says. This is put in, this is provided as part of the pod spec, so either the developer or the deployer who is deploying the application defines this network policy. Right? Rather than going through this, let me just give you a switch to a demo because I think that will give you a better idea of this. Any other questions so far while I switch to the demo? Or comments? Any thoughts you'd like to add? So what I have here is basically 3 instances I've got in the cloud. So I've got one instance called the master, a couple of instances for worker nodes. So I'm going to use kubeadmin. Everyone has their favorite deployment tool for Kubernetes. I tend to use kubeadmin a lot, but there's a lot that are pretty easy. It's pretty quick to get things going on kubeadmin. So what I would do is on the master, I would say kubeadmin init. It takes, depending on how long it takes to pull down the images, it's usually 15 to 30 seconds. And done. I can start looking at what's happening here. Okay, so the kubeadmin init works. Essentially, what the kubeadmin init has done is it's set up all the Kubernetes daemons on the master node, and now it's waiting for worker nodes to join the cluster. And so on the master, we look at the pods running. Right now, there's not very much running. The next thing we will do is we will run Calico as a daemon set. So essentially, what we're running is all of the Calico pods, the Calico node, which is Phoenix and Bird, and CNI, and all of that we encapsulate into a manifest. Calico node is running as a daemon set, which means that anytime a new node comes up into the cluster, the first pod that will always run is a Calico node pod, which means it can establish network connectivity, and so Calico gets set up automatically. So all you do is you would do and I'm running a version of Calico which has some of the additional monitoring and operational features that Tigera as a company builds on top of Calico. So I'm just going to run this as a manifest, which sets up all of the, it sets up Calico XCD as a service, it sets up Calico node as a daemon set, it sets up the CNAP plugin, and essentially it's running as a pod in Kubernetes. So it typically takes a few seconds for the various components to launch. So it looks like it's there. Okay. And now we can join worker nodes into the cluster by just cutting and pasting this command. Let's do that in the other node as well. So you should see the Calico nodes pop up for each of those worker nodes, which should be up in a second. So there you go. So now you have your DNS takes a few seconds. But essentially you have your Kubernetes cluster up and running. Yes. There you go. All right, so there's your Kubernetes cluster up and running. For those of you who haven't tried Kubernetes yet, that's all it takes. There's actually easier ways to install Kubernetes too. This is actually one of the easier ones, but there's even simpler ones. So there's your cluster. So now what I'm actually used to demo the cluster is a little application. It's just a test application we have called Stars. So if I go back to the master here, and what I'll let me run this here. So I'm first going to run the Stars non-PCR version, and essentially what it's doing is launching sort of 3 pods here. One is a management UI, which we're going to connect to and show what this looks like. The management UI has essentially is polling some pods on the back end, or polling applications on a certain port, and will report back whether it can reach that application. And the application is also polling other components of the application, so it sort of reports back on what connectivity is possible. So here, if you do I haven't set up a load balance, so I just have it set up as a service. And so this is right now running as a service on management UI's port 30002. So if I go in and connect to my master here on port, this is your management UI. So essentially what I have in the application is I have a client pod, I have a front-end pod, and a back-end pod. So it's sort of mimicking a three-tier application where you have a client talking to a front-end, just talking to a back-end. In this case, it's all pods running in Kubernetes. One of the things I didn't mention when I talked about Calico features is Calico Policy. In addition to doing policy enforcement in Kubernetes, you can also do policy enforcement on host instances. So if you had a database instance running on a bare metal node in your on-premises environment, or on a host instance on the cloud, you can turn off the networking portion of Calico, simply do the policy portion, and Calico does the policy enforcement on the host Ethernet interfaces, but using the same set of label artifacts that you would assign to Kubernetes pods. So if you have something labeled database, you can use that in the same sort of common policy model with Kubernetes.
You're able to do that because you're using the standard network, IP network.
Exactly.
So that requires you to be paired with your network that your database.
Actually, no. So let me take that back, because Calico in host enforcement, we actually turn off the network. You can assume that if you have a host instance or a bare metal node, you've already given it an IP address. We don't bother with anything. All we do is the IPsec enforcement on the host interface.
Got it. So you put Felix agent on
Exactly.
the database. So
Exactly. So one option is you can put a Felix agent on the database host, let's say running Linux or something on data control. Or in the case of OS is not on data control, or you don't have the ability to connect, you don't put anything on the host. You simply know the IP address of that host, and you sideload that policy and labels into the Calico data store using Calico Kernel, which means you can do protection from the Kubernetes side out, but you cannot protect the other side in.
Like other VMs or something.
Exactly.
It would need access to etcd.
Correct. In the case of host policy, you would need etcd. We could also do it with the Kubernetes data store as well.
Oh, even outside.
Exactly. So this is one instance. So let's do this. So let's make this fun, and we'll add a second version. I'll show you what this looks like. Essentially, what this is an application with a service and a replication controller. I basically have given it a couple of labels. Role equals backend 2. I've given it another label saying compliance equals PCI. And essentially, the application is simply polling these different URLs and reporting back connectivity. So the fact is now it's showing connectivity between these sort of pods. And it actually looks better on here than it does on Zoom. The graphics kind of you go over the network, it seems to slow it down a bit. So also have to do, I need to add this into the UI. Right now it's sort of a manual process for me. So I will simply do that by adding this JSON artifacts into the UI. And now if I go back, it takes a few seconds actually usually. There we go. So now you have a second back end and a second front end. The client can talk to the front ends and the back ends. Literally everything can talk to everything for the most part. This is just with 2 instances of the application. In the real world, where you have dozens or hundreds, you can imagine what the connectivity patterns are like. But those of you who don't have network policy, anything can talk to everything. Which means that if there's a flaw in or a known issue in one of your components, and someone had attacked that, essentially they have free range over everything else. Guess what happened to Equifax, right? That's what we're trying to avoid here. So how do we avoid this? Let's do a couple of things. First, we will do a incredible namespace. We'll turn on default and deny on the namespace. And we'll also do that with the stars namespace with the stars application. And what that means is now we're in that namespace for that application, we're saying don't allow anything to talk to anything. Which means, guess what? What happens is even the management UI can't talk to any application. So we'll have to allow the management UI to talk to stuff. UI all, which is basically just saying the management UI is allowed to talk to everything. And so now if you go back and go reload, so you get the same picture, except now none of the pods are able to talk to any of the pods. That's anything that's able to talk to things is the management UI, which is not very good either because now your application isn't doing anything useful. So let's add some additional policy. Let's first allow the front end, which is basically saying the front end is allowed to, or the client is allowed to talk to the front end over port 80 and port 443, right? So the 2 front end instances. So now if you do a shift reload here, all right. So now we have the client able to talk to the front end. Now let's do the back end.
In the current image, what is the light shaded lines?
It's basically saying it's trying to ping on that, but it's not able to connect, right? It's showing the
Theoretically could be a connection if you
yeah,
allow.
it's trying that, but it's failing. So we tried the backend policy. So basically the same concept in your network policy. Say front end is allowed to talk to the back end over port 6379 and 63, right? That's all. Let's say. And so now do a shift reload. Voila. So now you have the client able to talk to the 2 front ends. The 2 front ends are able to talk to the 2 back ends.
Do these policies stack?
Absolutely. So essentially in Calico, there's sort of a linear ordering and there's sort of by default, there's a default order, which is order 1000.
Okay.
And so then if different policies, depending on how you define them, you can actually have sort of a straightforward sequencing.
Okay, so it's somewhat like IP tables.
Essentially, it's a higher level policy language. Calico implements it using IP tables. So for example, they go to one of the nodes here and do a, let's see, watch dash D, IP table, dash C for counters. You will see the, I can make this bigger. You will see sort of the counters change on depending on which policy is being called to deny packets, right? So you can see in one glance. And if you pick your policy names to be small enough, you can actually directly, Calico puts the policy name here. So you can actually directly look at the IP table and say this policy is what's denying it. But this is where I'm going to demo some of the bit higher level operational tools that give you more in-depth detail as well, right? So let me quit that and go back to the master.
this isn't a totally new pattern, right? This is what security groups are in Amazon. It's roughly the same thing, right?
Correct.
It's not necessarily as flexible, but.
Exactly, but this is dynamic, it's based on labels, right? And it's sort of in lockstep with Kubernetes, because as Kubernetes spins up new pods, each pod gets an IP address. And the network policy follows the labels, not the IP address.
Which, is why I would, compare it to security groups. Security groups just matters what they're attached to.
Exactly.
I think the label system would be better, but
Exactly right. And security groups is sort of a coarse-grained isolation,
yeah.
but it doesn't work too well. Firewalls in sort of on-premises environments do. But they usually can't deal with the fact that IP addresses are much more transient fleeting in something like Kubernetes.
Oh, yeah, and it doesn't.
Question?
So initially, before having this kind of things, when we got to know about this Kubernetes things, my first question was about multi-tenancy. And as you may know, like the initial community talked about a lot of things, okay, how you can really deal with multi-tenancy. And someone actually answered, kind of an incorrect way for me, like, okay, namespace resolved that multi-tenancy. And back then I was not, aware about the meaning of, namespace, and I realized, no, that's not really multi-tenancy at all.
Right.
And then this thing, I think really kind of resolving or providing some complementary solution.
Is,
right?
but it goes beyond this, because when you look at multi-tenancy, there's other elements of RBAC and ABAC that come into play as well. And so you have to rely on other Kubernetes artifacts, including RBAC, which can tie into Calico Policy and other sort of components there as well. Right? So multi-tenancy is sort of you have to look at it in multiple dimensions, but this is sort of feeds into that bigger picture of multi-tenancy. Good comment. Yeah.
Do you see Istio replacing this network policy or supplementing, or how do you see that going?
Right, so we see Istio and Envoy specifically complementing Calico network policy. What Istio does really well is layer 5 to 7, because it can look at things like application headers, HTTP headers. And keep in mind that in the Istio and Envoy's case, the Envoy is running inside the pod. Calico is enforcing this at the host. So even if sort of the pod things break out or you don't trust the pod, you still have this enforcement at the host. Also, this is being done in a very optimal lookup in the kernel, like it's an instant lookup. There's a lot of things you can do by just doing some of this policy enforcement in the kernel with Calico, so you don't have to bother sort of Istio and Envoy to do some of that. The other factor is that Istio and Envoy specifically have a certain set of protocols they support today. They support HTTP 2 and 1.1. They support gRPC, obviously. They're working on TCP. TCP is there now. It doesn't do things like UDP yet. It doesn't do a whole bunch of other protocols. It does MongoDB. There's a couple of others. Calico is it's just any layer 2, a layer 3, or layer 4 protocol, right? So it's pretty standard. Also, Calico does the policy and ties it into the networking infrastructure as well. So it's very complementary. But that said, there's a lot of work we're doing on sort of getting a simplified view across that whole stack. For us, we look at this layer 3 to 7 as sort of like having sort of a consistent policy working across different layers. That's one of the reasons we really jumped on board with this queue early on. We think there's a lot of benefit to it.
Cool.
So here's where we are today. So we got the client that can talk to the front ends. We got the front ends that can talk to the back ends. But the reason we labeled it PCI says, if you're PCI compliant, then you have to have all these boundaries over what can talk to what. So maybe we want to say now only PCI compliant pods can talk to other PCI compliant pods. This is where there's sort of additional capabilities in Calico Policy using additional operational tooling we call essentials. And what this is, it gives you things like policy tiers. So this is policy so far. Everything we've done is Kubernetes network policy. It's the developers defined it. If the developer wants to connect into a host instance, you can use Calico Policy perfectly fine. But what if I, as a business owner, I'm going to say now I cannot allow my PCI pods to talk to a non-PCI pod? Or I might have a production pod and a non-production, it's like a staging. I want to keep those separate, right? There's sort of different ways you can use this. So the way we would do that is doing So this is what we have right now, which is the default order of 1000, and these are the policies we have right now. We also have, as part of this toolkit, we have tools like Calico Q, so you can look at a given node and it'll tell you all the workloads running in the node, what policies are affecting them. So this is giving you better sort of visibility rather than going and looking at things like IP tables. Or you can do this based on workload or policy. Okay, so Calico Q policy is start backend policy. And it tells me right now I have these two workloads matching that policy, right? So you can go back and drill down into what policy is affecting what in your application. So being able to drill down further, you can actually evaluate individual selectors so you can see which pods of policy will apply on. So you can go into a lot of in-depth granularity. But coming back to what we're trying to do here, we're trying to now isolate the PCI compliant pods from the non-PCI compliant. And the way we would do that is we would do and this we do with Calico Kernel because this is a Calico feature, or a Calico Essentials feature, not a Kubernetes feature. Let's create an InfoSec tier, which basically is, I'm just creating a new tier with an order of 100, which means it's higher priority than what the default is. And you can create, arbitrary tiers as many numbers as you have. And let's also do a PCI compliant policy as part of this InfoSec tier. And what this looks like is essentially what I'm saying here is that client and management UI is allowed to talk to everything, or everything that other layers allow it to talk to. So it's basically doing a pass, which means the higher level policy would apply. But then for anything labeled PCI compliance, if it's allowed, if the thing that's trying to talk to is labeled PCI compliant, then I'm saying pass, which means the higher level policy will then come into play. Everything else I'm denying. So something that's non-PCI compliant is trying to talk to something that's labeled PCI, they should deny it. So since we applied this InfoSec tier policy, let's see what the graph looks like now. Voila. So you have your client that can talk to both front-end pods, but only the front-end pod labeled PCI compliant is able to talk to the back-end pod labeled PCI compliant. The front-end pod that doesn't have the PCI compliant label is unable to talk to the back-end pod labeled PCI compliant. Right? So that way you have your boundaries, or it could be production or staging. You could create your arbitrary labels. But now as an InfoSec team, you can then say, I'm going to prevent this because my business policies aren't going to allow it. Or you might say things like, maybe I'm under active attack right now. And there's a set of attack vectors which I need to protect. And it doesn't matter what the developer has put in network policy. I'm now going to come in at a higher priority and say the network ops or an InfoSec team, I'm going to prevent all traffic in this block or to this set of pods. I'm going to do additional logging. And to give you an idea of what the logging looks like, so I can do things like you can do things like log and drop on, let's say, node 2. So if I go to node 2 and I do a now I'm getting sort of in-depth 5-tuple information on what packets are what packets are being dropped. So you can go back and trace the source addresses. You can go back and look at where it might be a sort of a valid attack that's happening. But here's another example. You might also have a situation where you define network policy, but you might have made a mistake in network policy. And so we have other ways you can sort of test it. So instead of log and drop, you might have, say, a log and accept. So on node 2, we're just going to accept all traffic, even though network policy says drop. But what we're doing is we're logging information to syslog. So now you're still getting the logs. So you know that this is sort of something that network policy would have dropped, but you're allowing the traffic anyway because you may not want to cause an outage for a production application. You can go back, correct your network policy, or see if it's an actual legitimate attack, and then go back and fix it. So this is a way to sort of override your network policy rules with sort of a, typically when you're deploying an application. This sort of simplest comparison I can draw is how many of you guys have used SC Linux?
Yeah, so I was just thinking it sounded like.
Exactly. So SC Linux, when you can have a sort of a policy module and enforcing that says, if it's not in policy, I'm going to deny it. For a lot of people, when they're testing policy, they have this permissive mode where you log it and then you go back fix your policy, or you use tools to fix your policy. And this is sort of a similar example.
So you scoped it at a node level. Can you just apply it globally, or?
Yeah, right now,
right
it's at the node level. But we're looking at expanding it to other sort of
Right now, it's always at the node.
It's at the node level. So you can do it on a node by node basis. Doing it globally, there's ways to script around that, but yeah.
Okay, but you're expected to. I mean, I can script around it.
Yeah, but that's something that we're actually looking at as well as adding in the future.
I'm thinking like, I want to turn on security policy and start writing them, but I don't want to break everything while I'm writing them. So.
I hear you.
Okay.
Talk to us on Slack, give us your feedback.
Okay, no, that's.
So as far as the OpenShift also using their own kind of a policy stuff, I don't know exactly matching with this guy, when internally they're actually using OBS still.
Yeah, so let me talk about OpenShift. So I actually know the OpenShift. I actually helped build out some of the cloud ecosystem for Red Hat, going back to a previous job. Calico today actually works with OpenShift. Red Hat is certified Calico. It can be installed as part of the OpenShift Ansible. This would replace the OpenShift SDN, which has either a network policy mode or a multi-tenant mode or a subnet mode. But those use layer 2 artifacts, and it also has a very rudimentary network policy. What you would get if you use Calico instead of OpenShift SDN is obviously all of the networking functions of Calico, the policy functions of Calico, plus all of these essentials of the commercial product built on top of Calico. But we actually do have a growing number of customers that are interested in Calico within OpenShift. It's something we announced with OpenShift 3.6 like a month and a half ago. So it is brand new, but it's actually available now. But it would basically replace the OpenShift networking. And Red Hat guys, by the way, love it. They find the functionality that they're getting with this. And there's sort of numerous things that when you have an overlay, trying to connect things to outside the overlay is not easy. You're sort of forced into an ingress and egress controller. There's a bunch of artifacts there which in the real world start to break things, and Calico make all of those possible. So they actually love what Calico brings to the table for them.
I get it, but when we heard about SDN, when they talk about SDN, they say, okay, overlay is the right definition. You know what I mean? Like they're all using overlay network. Now you say, okay, overlay is.
We'll talk offline because depending who you're talking to, I know I actually worked with the Red Hat guys. I know them pretty well.
Okay.
Other questions or comments? So one other thing I was going to show very quickly is, so if I do a couple apply. Actually, this was the YAML I was working on the flight over, so fingers crossed, let's see if it works. All right, make sure it's working. So I'm starting out Prometheus operator, and I'm going to run Prometheus to give create a collector for all the statistics that Felix is exporting, including policy, stats, what's being dropped. Okay, so that's running. So now let's.
So you can export in VS format natively?
Sorry.
For Prometheus software, you just export all that data.
Quick question. I need to go back and look at that. But let me take that one in terms of what's the actual format we have to plug in. And Okay, so now I'm creating the actual Prometheus with Alert Manager. The Slack may or may not work. I've been using a Slack channel for demos. Unfortunately, when I turn on logging, there's a ton of messages because I set the threshold to be anytime that 2 packets are violated, send a message via Slack. I don't know if Slack's turned me off as you'll see. All right, so that's running. All right, so now Prometheus is running on 30909. Okay, so if I go to so there's my Prometheus, and if I look at Calico denied packets, for example, hopefully I should see. There you go. So you see the packets starting to go up for the demo we just created, right? So you're seeing stats. And from this, you can sort of create alerts and don't know if this is actually going to work on Slack. Yeah, it's not. It's they've cut me off since like 11 a.m. probably because but essentially you can do. I mean, with Prometheus you can send alerts to your favorite alert manager. I'm using Slack as an example, but you know, pick your favorite operational tool. So sorry.
So are there any good UI management policy tools that are out there? Do you spot them?
So first of all, with Tigera Essentials, so Calico is all open source. All the network policy is open source. The host protection is all open source. Tigera as a company is focused on building and obviously continuing to drive the open source community around application connectivity, but also around the operational tools to help people who are deploying this in production at scale, help them with all of the tooling. So that's a conversation we should have as part of the Essentials thing. And so there's lots of things happening there. What you have here is things like API access, Calico queue to be able to do this on a cluster of hundreds or thousands of nodes, on Calico Cuddle. So for example, doing a
This is part of the essentials, not the open.
no, this is all, Calico Cuddle is open source,
Yeah.
but things like the policy tiers
Okay.
is the commercial product.
What's the difference between running the commercial product and running the normal one? Different controller/nodes?
Essentially, the way you would get the commercial product is it's a special, if you're using the Calico node image, it's a slightly enhanced version of that gives you the additional instrumentation, the additional sort of tiering policies, that sort of stuff. But aside from that, it's just changing the container.
Oh, it's
Just changing the image into that product. But this gives you the additional features and things like tiers, and this is the bug I was working on someone with, where you see the nil, it should actually say 100. But yeah, essentially that's those are the kinds of features where you get higher priorities, where you have an organization that may want to override what the developer says, maybe, and if you're seeing a real-time attack, or maybe you want to have a policy that says, I don't care if my developer says he can connect to everything, I'm going to restrict him to only internal hosts. Or if you're using a random DNS or using the Google DNS, I'm going to force him to use an internal DNS, right? So having those sort of overrides. And sort of policy troubleshooting at scale, the audit mode, to be able to, when you help move an application to production, sort of help get more in-depth logging, by tuple data, other sort of in-depth packet captures. So you can go back and troubleshoot and create a new more in-depth sort of. And these are all things that you don't care about as a developer. It's someone that's deploying and managing and operating a network that's going to care about these sorts of features. And again, all of these features on the UI, there's sort of an ongoing roadmap. So Essentials Toolkit is something that we don't release as a once a year or twice a year release. It's sort of a continuous once a month release with new features. So every month there's a new feature release. And if you go to Tigera.io, we have sort of white papers, reference architectures, talking about, so policy tiers came in 2 months ago. The month before that, we had violation alerting. There's a new release coming up this month. End of this month, that will have some new features as well. So it's sort of an ongoing update. Any other comments, feedback? That was sort of the high presentation I had in the demo. I'm pretty thankful that Prometheus worked. What are your thoughts in terms of, so for those of you who've been doing Kubernetes, but haven't sort of gotten into depth on networking yet, or haven't used Calico yet?
I was just gonna say, besides the network policies and using easy networking, are there any other advantages to not like switching from Flannel, like speed or?
Yeah, so let's talk about Flannel versus Calico, right? So first of all, we are co-maintainers of Flannel. We love Flannel as well. And Flannel, the way it works is Calico, we exchange routes among nodes using BGP. Flannel has a variety of backends that it can use. So the thing that most people use is a VXLAN backend. So you use a VXLAN encapsulation to get packets between nodes, and that works across across multiple sort of AZs, for example. The other backend that a lot of people use is something called host gateway, where you assume layer 2 adjacency and you basically create routes in the Linux routing table, assuming that the remote node is directly connected. So you create a /24 route. So Flannel in host gateway mode also works without encapsulation, but that works in a single subnet. Now there's someone that configured a patch for an IP mode in Flannel, which we are working on triaging. Flannel has a backend mode for AWS, where it creates routes in the AWS routing table, which means you can do routing across AZs, but you're limited to it. Amazon's limited to 50 routes in the routing table, so it works in small clusters. So Flannel is perfectly okay as well, and you have sort of Calico Policy that ties all of this together. The main difference is things like here in Calico, if I go here and do a IP route show, essentially what you see here is you will see a route that there's too many pods running. Let's try this. Yeah. So essentially, for every pod that's running on this host, you see a route for that IP address pointing to the interface, and you see for the routes via BGP, a /26 route for the pods on remote nodes. So it's simple IP traffic. Troubleshooting is just short things, how you would troubleshoot connectivity on your laptop, not too hard. The same thing in Flannel with VXLAN, it'll be pointing to a Flannel daemon, which would be doing VXLAN encapsulation. So yes, a little bit more overhead. And yeah, you have troubleshooting a VXLAN encapsulation. If you're using host gateway, you're not using encapsulation, so it's actually simpler. So Flannel, Calico, they're both perfectly good options. We tend to see that people who are doing networking at scale tend to start to move towards Calico because it works. You're using the same recipes that help you to scale to very large clusters. But if you're on a reasonable size cluster, Flannel should be okay as well.
Some say the performance of Flannel versus Calico is 20–30%. Is that true or not? Overhead.
I was actually doing some performance numbers over the weekend actually. I'll see if I can pull it up and even show you.
I mean, when I was looking at choosing one for us, we're doing throughout the whole product about 1 million pods a day just for one piece of it. And Calico has handled that just fine. I was looking at going, why would you?
So from a scale perspective, you feel like it scales better than Flannel?
Yeah, it's simpler. It made more sense to me, like to use this thing like, well, how do you know it'll handle a lot of performance? Like you said, it's route tables, it's IP route tables, like it's a no-brainer.
Yeah.
And the IPAM that you get from Calico is much more efficient. I think it assigns much smaller chunks to nodes at a time, so you don't get this like, you're taking your /16 and making a bunch of 24s, like wasting a ton of overhead. Like it's way more dynamic.
Okay.
Exactly. So with Calico, and even Flannel host gateway mode, you're not using any encapsulation. You're using standard network routing in Linux. So it's essentially we are not in the data path, right? So whatever you're getting on bare metal, you should be getting on Calico or Flannel and host gateway mode. So for example, you look at the numbers here. This was done on a cloud where we sort of constrained by the performance on the cloud. So depending on whether you're in the right placement group, you have to deal with sort of stuff they have going on behind the scenes. But here, if you see the node-to-node performance versus the pod-to-pod performance, so Calico or Flannel host gateway mode should be pretty much comparable, right? So if it's 11.1, it's 11 or 11.1, it should be the same. If you're doing IP/IP versus VXLAN, IP/IP is a little bit better than VXLAN because it's less overhead. It's just an IP packet. VXLAN, you're taking the Ethernet packet, putting it in an IP packet, which means it's Ethernet overhead and IP overhead plus more IP overhead. So it's a bit more packet overhead. But that's sort of what you're seeing. So you're seeing anywhere from 20% overhead to 25 to 30 to 40% in the case of VXLAN, right? Generally, that's what you tend to see.
We're trying to move our hosted VoIP infrastructure into Kubernetes, and that the media part, right, scares us because we can't have any network latency added.
Which is why people love Calico. It's essentially getting bare metal performance.
Okay.
The other reason is you actually, in SIP application, I run into this in a number of cases. Some of them, depending on the implementation, are sensitive to NAT.
Oh, very, yeah.
Right. So with Calico, you can actually use IP addresses that are directly reachable and avoid NAT altogether.
Okay.
And you can do that in a pod basis using the pod annotation. So you can say this pod is directly reachable externally and this pod is not, right? So you can sort of do that kind of advanced
That would be awesome.
networking.
Right now, our initial test, we're using host network, just because we didn't want to bypass it altogether, right? But
Which is, yeah, it's sort of a clunky way of doing it, but
is.
yeah.
Okay.
Other questions, feedback, comments? I have left some stickers that I'll also give you guys my cards. Feel free to reach out to us. We have a Calico user Slack channel that's pretty active. Always happy to keep helping folks there. Let's find the slides again.
You said you're also hanging out in SIG-Network, is that correct?
Yeah, we're pretty active at SIG-Network as well. So a bunch of my peers, and I tend to usually keep up with the summaries, just because there's so much that's happening in the Kubernetes community right now. But yeah, there's a lot of stuff happening. Like kubeproxy, there's work happening. Someone just did work around. So Calico has always supported IPv6, but Kubernetes still has a little ways to go. We're nearly there. But someone got IPv6 working for pod-to-pod traffic using Calico. They blogged about it. So people are pretty excited. And Kubernetes 1.9 kubeproxy now finally gets decent v6 support, just lagging a bit before that. But there's a bunch of different things going on. What else? Like I said, there's work going on MOI and Istio. There's work going on there's actually an interesting inflection point happening right now, in that now we're starting to see some of the more traditional telcos come on board as well. And they're like, oh, we want a traditional NFV application and do service chaining, which means we have to do it this way. And you need to have this sort of artifact of having multiple interfaces. And you find out, well, you can do that by just giving the Kubernetes model and doing network policy to isolate between applications. Oh, no, this is the way we do it. Fair enough, you can do that, but suddenly your code is going to be a whole lot bloated.
Yeah.
So the way the Kubernetes community decided to do that is to keep the core simple and to do this additional stuff by using PPRs or CRVs. So that way, if a plugin wants to go off and do the complex thing, go ahead and do that. But the rest of the folks that don't need that functionality have a simple, scalable approach, right? So generally, the SIG-Network has been on side of the right track, which we are happy because we've been helping drive it that way.
Yeah,
So,
I like it.
Before you go, can you explain I'm not 100% sure what the policy controller is for. I know that it's important, and I just moved it to being elected on our masters instead of running on a node somewhere, because when it wasn't running, everything was breaking. So
yeah, so what you're calling out is the fact that if you look at what's running in the I go back to the instance that we're running here. You see this thing called the Calico Policy Controller that's running. This is only applicable if you're running an SED mode. What the policy controller does is it watches the Kubernetes network policy, Kubernetes API server for new network policy objects, and copies that policy intent into Calico's etcd data store. If you're using KDD as the data store, we don't use that. We just watch the objects directly, right? But essentially, that's all its function is. And if you, like I said, it's only if you're using Calico and etcd mode.
Okay, yeah, and then which is what we found. I think it was only really necessary to do it in repositories, but it does some work when new namespaces get created.
Yeah, so there's a little bit of things here and there that it does.
Yeah, so it wasn't running and new namespace got and you couldn't talk it in the namespace.
Exactly. But the actual policy enforcement is done by every Felix agent independently. And it's sort of a very distributed way because there's no centralized coordination. We just use a data store like etcd or KDB. And we're not sort of coordinating among the Felixes. There's no centralized policy. There's no centralized SDN controller. We have a policy controller, but that's just for the high level policy.
That's just to bring in the resources to make the FTD, the Felix.
But Felix enforces that independently, right?
Okay.
And someone had the question of how this works in multiple clouds, right? So Calico is actually used behind the scenes in some of the larger public clouds. Someone talked about Google Container Engine, which uses Calico today. It's actually now in GCE. So if you spin up a Kubernetes cluster, it's actually using Calico for the policy enforcement. IBM have blogged about how they use Calico for networking and policy as part of their Bluemix hosted Kubernetes deployment. And they have a super cool architecture and how they've architected it. But essentially, they use Calico policy. I have a number of other sort of deployments at scale where they use Calico's policy, and that's all they rely on. One of the corner cases is Calico policy because it can do host protection. You can use it for protecting the Kubernetes nodes themselves, in addition to the pods. So we actually have providers who turned off any other protection. Firewalls can't deal with sort of this dynamic IP address mobility and changes. So they just use Calico policy and do host protection, both for the Kubernetes nodes and for the sort of other cloud infrastructure hosts as well. In fact, we have people running, we have large customers, large storage service customers who are running Calico for, they're just throwing out their physical firewalls and they're running Linux nodes running Calico because it sort of ties their legacy bare metal infrastructure to the Kubernetes, to the host instances sort of very cleanly. Right?
Do you have any examples or anything written on that? Because my question was going to be, how would you integrate with like F5s and stuff?
Absolutely. So, for example, one thing to tune into if you're looking at doing this on the public clouds like GCE, Google did a webinar on this recently, and it's actually recorded and available. I think they might do that again. IBM have written some blog posts, but we also have, if you go to the projectcalico.org website, we have blog posts. This topic of host protection and pod protection is something I have on my list for the next 2 or 3 weeks, so we'll get that out pretty soon. But we also have some other blog posts that are in the topic. Or if you go to this place, projectcalico.org. Using Calico for host protection, that gives you an idea of how host protection works, right? So it gives you sort of in-depth details. So you can actually just look at the project docs. Docs is something that's continuing to improve as well, so that's ongoing work there. But it tells you how to do this, how we have a case where we're protecting Kubernetes nodes itself, how to make that work with your proxy. So that's sort of docs there, and we go to our Slack channel for this was sort of what you were talking about, right? So if you're using Calico for Kubernetes, you can actually run Calico on other orchestrators too, like OpenStack, Mesos. And as far as Calico is concerned, networking is just simple IP routing, and then you use policy to define what you want what. But you can have this on a host, you can have this on a host where you don't have control, where you're protecting egress from the Kubernetes side out. I think that is what you're talking about. I mentioned storage and service, that's Box, obviously. That's sort of a little bit of a humble boast and humble brag, I suppose. Who's using Calico today? I had the links, but also had this, I think, for the question you asked, which is what network option do you? Go back and read 8140 because it's in terms of internet RFCs, every so often you come up with a RFC that pokes fun of how people do things. And this one's a funny one because it talks about, this concept of SDN as it sort of evolved. And people have all these wonderful images of unicorns running around and how the world is such a wonderful, fun place. But the reality of, especially when you look at the more complex overlay-based approaches with sort of a process complex SDN controller on top of it that's trying to orchestrate paths for the network and have path computation elements. For those of you who sort of built networks back in the day, and you go back to the late 80s or early 90s and think about, back then there used to be this thing called X25 with pads, and then you had this sort of centralized database, that's based on X file 100, that is going to compute this path for the network, and it'll set up the circuit switched path, and it'll be plumbed, and it'll all be perfect, right? It'll work at scale. Instead, the world we ended up in was the internet. Well, nothing is perfect. Things break all the time, but IP and routing work, right? And that's the approach that Calico is bringing, is IP and routing work. And we just use those same principles that have worked well for us. We're not taking this sort of traditional circuit switch path, which is what a lot of people are trying to do with things like OVS and OVN, and trying to sort of create decentralized SDN controller model, versus the approach we're taking is to keep things distributed and simple.
So what's your view on MPLS?
Yeah, so MPLS, so for example, the comparison I will draw is if you look at Kubernetes, one of the other plugins available is something like Contra, which uses BGP MPLS, right? And so the challenge there is typically in an approach like that, you have some sort of a module, like in that case, they have a vRouter module, which is something that's in the kernel, it's a kernel module, sort of in the data path. Calico tends to keep things simple, we're just doing IP. We're not using any overlay, whether it's a layer 2 overlay or a layer 3 overlay. A layer 3 overlay, my personal opinion, I tend to think it's a little bit better than layer 2 overlay. But what Calico is saying is, if you can avoid overlays, just avoid them altogether. It makes life even simpler, right? Especially in the case of clouds, where you already have cloud providers with their own overlay. Why would you want to add another overlay on top of it, right? Just avoid it altogether. So yeah, MPLS is one sort of approach for creating an overlay. And it's probably a little bit better than trying to create a layer 2 overlay, but it's still an overlay.
I would say like depending on target use cases.
Agreed. And that's a fair point. I'm just going to say, because come back at a disclaimer, because someone will come back with a use case that says, I have this sort of corner case, which maybe that corner case is less, different plugins have their own sort of value proposition. We have ours with the Calico Cloud.
Well, kind of going over is.
I know.
I think what we'll do is we'll just say thank you.
Thanks. I'll be around, yeah.
Yeah, if anyone wants to just have some private conversation, whatever. Slack channel, those that haven't been on the Slack channel, we have a Slack channel for us. You can sign up. Post it on, I think it's on the Meetup area. Let's vote again what we want to do for November. I'm going to say we're going to cancel November. I think I'll just do that. I think we'll just do that because it's too close to Thanksgiving. There's just too much going on. And then we'll just do that 18th. We're going to use in December. We'll see if we can get some other individuals in. It's just amazing.
Well, can I do a quick plug? I'll just mention a couple of things. So obviously we have a Slack channel as well. Calico users, I've got a Project Calico, obviously a link to the Slack channel. But we also, as a company, we also launched training classes. So we now have 4 different training classes. One on Istio, which is an 8-hour class on using Istio and Envoy. We have one on Introduction to Kubernetes Networking, which is a half-day class walking you through all of these sort of artifacts using Calico and Flannel. We have an 8-hour class on Advanced Kubernetes Networking and Policy, going into a lot more depth on how it works with Kubernetes. And for those of you already managing clusters, for example, if you're using Calico already, we have a 4-hour class on operating Calico and operating Kubernetes networking in production. Not just covering Calico, but also covering other Kubernetes artifacts, DNS, proxy.
Is this on site or you have?
It's online. We also have on-site. I think the next on-site one is in San Francisco, but the online one is we offer one every 3 or 4 weeks. So in fact, I think we have one that's also a free offering that's coming up.